Hey everyone, welcome to the stream. This is Josh Justice, aka Coding It Wrong, and as I always say, you'll have to watch to see if you agree that I'm coding it wrong. I'm here, it's Tuesday, very excited. I'm off for the holidays, so I'm pumped about that. Low on sleep, so it's going to be a bit of a crazy stream today, I think, a little loopy. It's going to be interesting to see where that goes. I'm just excited to be here together, talking about TDD in JavaScript. So we have a fun exercise today that I want to talk about, I want to introduce, and so let's go to the desktop, I can show you that. It's the Exercism IO exercise on the JavaScript track, and probably it's on other tracks as well, D&D character. So if anyone's ever played Dungeons & Dragons, or a lot of role-playing games, you know that character attributes, these numeric values, are randomly generated. And so we're going to get to work on test driving some code with random values. And when I was going through this exercise, I was so pumped because there's so many unique things that came up and cool things that emerged as I tried to figure out how can we really specify what we need this code to do. This exercise shows a really great way that TDD is valuable. So here's my list of things that I say about why it's valuable to learn TDD. And in this case, which one of these would I compare this to? No, I don't have to test it. Where's this? Stay there. Yeah, okay, let's go back off that. I don't know which of those points this relates to. But what I found going through this exercise was when the code was already written, it was very hard to know how to test this random code. And so it was very easy to say when you're writing the test after the fact, all right, well, I guess this is good enough. I guess that's the best I can do, testing random code, and to move on. But when you're test driving the code, where you don't write the production code until you have a test that's pushing you there, it's specifying that you need it, all of a sudden you're forced into creativity. And it doesn't mean that you automatically figure out and get all the answers. It was hard. I'm drawing on experience. But I think feeling that pain of, is there a way that I can drive myself to implement this code so that my tests really cover it and specify it? It's a really great thing. And we'll see that together as we go together. Sean Jane says, hello. Will there be a recording for this too? Have to share this with my friend. Yes, Sean Jane, thank you for asking. All of my streams are recorded and they'll be up on my YouTube channel. It's linked from my Twitch page. The recordings will be up on Twitch temporarily as well, but you can always go to codingitwrong.com and links to my YouTube are on there as well. All those recordings will be available as long as YouTube is, which is probably forever. So please share with your friend. And I will say to Sean Jane as well as anyone else, if you're here in the chat or you're watching this video afterwards on YouTube, please say hello in the chat or the comments. Please let me know you're here. If it's helpful, let me know. If it's not helpful, definitely let me know because I want to do better. And I would love for folks to share questions. Do you have a question about something I'm working on or about some other scenario for testing or test driving? Do you have a challenge, something that you'd love to see me test drive? And maybe we can work on that in an upcoming stream. So please share that. I would love to see that. All right, so with that, let's jump into this exercise and talk about it. I've gotten started on the code already because I've started with, when we get, as a reminder, in Exercism IO, these exercises all come with tests that are pre-written. And what I found here, this is no criticism to the authors of this exercise, I'm very thankful for it. The tests that they're written now are not actually written in the way that I would want to test drive them. And so we're going to actually adjust the tests as we go, and we're going to submit that. And I'm not in the mentored mode, so I don't have anyone to tell me that I did the wrong thing by changing the tests. Apparently it works. So checking out the test here that were given in this exercise, I will say as another brief reminder, if you don't have an Exercism account, sign up. It's really great. You can sign up for the JavaScript track and do this identical exercise. You can pick your programming language of choice, and the D&D exercise might be on there, or there are other awesome ones as well. So join me on Exercism. It's a lot of fun. The first test we have is for this function called ability modifier. This is just sort of a helper function that takes in the number of an ability value and it gives you a modifier value back. It's just a very simple, pure function. There's not a whole lot interesting there, and so I've skipped over that for the sake of this demo to jump straight into the randomization issues. And okay, we're moving on here. We're looking at the tests as they're shared. Oh, yeah, I'm sharing my screen yet. Ability modifier, like I was saying, there's that ability modifier function that I was talking about. It's just a simple input and output. So we're going to skip over that to stay focused on these random values. So next we have a test here, a group that says ability scores calculated properly. And then a test that's disabled by the default, ability within range. So we see here we call character.roll ability, and then it's supposed to be less than or equal to 18 and greater than or equal to 3. It's going to give us random values, and so we don't know exactly what that value is going to be, but we know that it's going to be somewhere in that range. So let's uncomment this test, run the test, and see. We're getting this error that's almost always the case for Exercism. For JavaScript, it says remove this statement to implement this function, so it lets us know where that function is going to be. So we'll just remove that error statement for now and see what error we get. Now it says undefined, ability within range. So character roll ability needs to be less than or equal to 18, greater than or equal to 3, and right now we're getting back undefined. So I always say that we want to implement the simplest possible code to make the test pass. So in the TDD cycle, red to watch a test fail, green, get the test to pass in the simplest way possible, and then refactor to rearrange the code. But don't add more functionality, wait for the test to drive you there. So what is the simplest way we can get this test to pass? Well, we just need it to be less than or equal to 18 or greater than or equal to 3, so I just say return 3. So our test is passed. Our ability is within range. All right, so moving on to the next test. Ability score is only calculated once. So now we've got this character, Drizzt. It's apparently a Dungeons & Dragons thing I read about. And this character's strength needs to be equal to this character's strength. So the values don't need to be randomly calculated each time. They need to stay consistent. Sean Jane says in the chat, Sean Jane, tests are written in which framework, mate? Is it cool if I ask questions in between? I don't want to disturb your flow. Yes, I would absolutely encourage you to ask questions. Thank you so much. Especially if you're thinking of asking repeated questions. I'll just wait until I kind of get a break of a kind of flow of thought that I have, and then I'll jump over to the chat there. These tests are written in the Jest framework, and this is a really great framework for JavaScript testing in Node on the server side, as well as for React, Vue.js on the front end as well. So I love Jest and highly recommend it. And yeah, thanks again. Please ask other questions in the chat, and we'll connect over the course of the hour. So the second test, again, this is this character. We're making sure the strength is equal to the strength, but we've made a big jump here. We've moved on from this general static method on the character class, rollability, to making an instance of the character, and there is a strength. And so there's just a lot that we've jumped over. So I want to zoom back and go back. What is the rollability function? We've moved on as though rollability is done, but I'm pretty sure that having a 3 for every value is not what we want. It's not going to make a very exciting role-playing game if every character's every ability is exactly the same. So I think we want randomization in here. So one of the problems that occurs here is that when we have these tests that just say, oh, it's random, I don't know, but it needs to be less than or equal to 18 and greater than or equal to 3, is not actually driving us to implement the richness of the functionality. And so it would be great if we could specify what's happening there other than just a range. There's another problem as well, and we can see this if we, let me see here. Let's say we say, okay, the test isn't driving us to the random implementation, but we know we're going to want it, so let's type it in. I say 1 plus math floor. I looked this up. I'm reading this off in notes. This is how I know this. So to get like a random dice roll for an ability, it's like math roll random times 7. So it's like random is a value 0 and less than 1.0 times 7 is going to give us a range, and then we add the 1 to get it in the range of the numbers that we want. So this should give us our dice, and so we save it, and oh good, we're still great. Like this random number in this range is within between 18 and 3, so that's really great. So let's just run it a few more times to make sure we're good. Save. Oh, and now it's failed. So this time the value is actually 2. We expect it to be greater than or equal to 3, but it was 2, so that's weird. It's kind of hard to see based on the logic. Like it really just stretches my brain how these random numbers are working. So let me just save it again. So if I save it again, it's fine. It's fine a few times in a row, and then it fails again, and this time it's 1 instead of 3. So as we look at this, the problem is we don't have deterministic tests. Tests will sometimes pass and sometimes fail. And for unit tests, you want your tests to succeed deterministically. So you don't want to push your test up to continuous integration. They pass, you merge down your PR, and then your friend that pulls in the code, their CI fails because you have a random test that's sometimes failing. So we want something more deterministic than this. So that's two different problems with this kind of approach to testing random numbers. So how can we approach this? How can we make this better? The solution is to think about kind of splitting up your code. And what you want to do is to split up parts of it so that the randomization is different than the calculations that are happening. So for rollability, we want something more than just it's somewhere in this range. And actually, our requirements specify for us. It says, abilities have scores that are determined randomly. You do this by rolling 4 6-sided dice and recording the sum of the largest 3 dice. You do this 6 times, once for each ability. Okay, so we want to roll 4 6-sided dice. And so what we can do is to separate out the randomness and say, in my test, I'm going to specify the random results that you got. We can do this by injecting a dependency, basically passing in an argument that's going to be used instead of pulling in these random values. And so let's take a look at here. So instead of saying that we want the value to be greater than or equal to 3, I think what would be great would be to have a test case that actually gives us a value back of 3. And so let's write out a test for that. Test returns 3 when ... So what is the when? When should it return 3? And we're going to control those circumstances to get it to happen. Expect character roll ability, and we're going to pass something in, and then we want it to equal 3. So when should the ability be 3? Well, let's take a look. You do this by rolling 4 6-sided dice and record the sum of the largest 3 dice. All right, so this would be like the lowest roll that we could get. So maybe what we pass in, like maybe we want some kind of rolls that are the random values. So instead of math random, we want 0.0, like the lowest that we could get, and make sure that that's right. So we roll 4 rolls that are all zeros. But this is making the test hard to follow. Like, what does it mean? I'm getting 4 rolls of 0.0. How would I know what other tests are supposed to be? And so I think in this case, we actually have multiple levels of abstraction. Our attributes, we want those implemented in terms of dice rolls. And then separately from that, we want to implement dice rolls in terms of the random number functionality that JavaScript provides for us. So really what I'd love to be able to do is say the dice rolls are 1, 1, 1, 1. And I want to say the attribute returns a 3 when the rolls are all 1s. That's the specification. That's an example of what this requirement is telling us. Like one scenario would be if I roll all 1s, then I want to get 3 back as a result. So let's take a look here. If this is the rolls we want, let's see how we can pass this into our function and make it work. What we want to be able to do, and let me pull up my little cheater helper code here to see how I munged this together. We want a function. We want a function that we can use in here, and when we really roll the ability, we want to be able to roll dice. Let me take this back out and kind of start from scratch. So I think what we want here is to be able to say, sorry here, I'm looking at my code here. I want to be able to pass into this rollability function a die roller. And we can call it roll die. So this is passing into dependency. This is the function that we use to roll a die and get a number back from 1 to 6. So we need to define this function. And we could say const roll die equals, this is a function that we can call. And so what do we return? Well, we can take these rolls and we can just say rolls.shift. So rolls.shift is going to shift the first number out of the array. So now we're passing this in. We're passing in this dependency that says, okay, for the sake of this test, when I roll a die, I want it to be deterministic. I want to say, in the scenario where I roll these 4 1s, here's what should happen. So how can we use this? Well, in our code here, we can take in that roll die, and now we have that argument, and we can implement our function in light of it. So how can we roll the die like that? So really here, we do still have just one test that's specifying that we return 3. So still, to make the test pass in the simplest way possible, we still just want to return 3. And actually, we're not even really using this argument at this point. So our test here, when the rolls are all 1s, we return 3. So that's great, but we want to go do better than that. We want to move on because we want to drive us to implement more functionality here to get our full functionality of rolling 4 6-sided dice and recording the sum of the largest 3 dice. So what's the next test scenario, the next example that we could think of? And I'm gonna leave that commented test up there. I'm gonna copy and paste it. I'm gonna say that, well, the next thing they could change is one of the dice could be a 2. So what would happen when one of the dice is a 2? We discard the lowest one, and then we add up the others. So that's gonna be a 4. So that seems like a nice, good test case. So it returns 4 when we get 1, 2, and 3 1s. So here we expect to get 4 as the output. We save, and return. We expected 4 and we got 3 back because it's hard-coded. So how can we implement this here? We could add a little conditional, but well, first of all, we do need to see our roll die. You need to get this argument. So what can we do with this roll die argument? You could check and see something, but I think anything we do to kind of hack around it is going to be more complex than just the simple implementation, which is, and I don't even know the best way to shift it, so let's just do it by hand here. Return roll die 0 plus roll die 1 plus roll die 2. Take the first 3 elements. Let's save that, and it failed, so I messed it up. Not a number. Oh yeah, roll die is not an array, it's a function. So we want to just call it 3 times, so that's actually going to make it easier. Roll die plus roll die plus roll die. We add that up, and our tests pass. So for our function here that works with these 1s, we get a 3 back, and with these 2s, we get a 4 back. So what's the next test case that we could think of? Well, before, we have our refactor step. So we had red where our tests failed, green where they passed. Now let's think about refactoring. I have a feeling we're going to have a lot of tests that are going to need to roll dice like this. So let's extract a helper function out of here. We have our roll die here. And so what's the best way to do this? We say make die roller. We pass in the rolls. And then we're going to return a function that just shifts the rolls out. And so then here we could say make die roller rolls. And make die roller rolls, and I bet you this will still work, and it does. Now we can probably inline these rolls, because that's probably simple enough. All right, and then we could probably remove that line break at this point. It probably reads simply enough. Yeah, so we're saying when we roll these things, we get this output. When we roll these things, we get this output. So I should pause here to say, I mean, we're starting to build out a real implementation, but this is the interface to use. We identified, hey, to really drive out the functionality of this class, we want to define it and specify it in terms of the roles. If I roll this, then I should get that. And so we've used this dependency injection to separate out the randomness and say, okay, we'll use real randomness in production. In my unit test, I'm going to call a function and I'm going to return those dice back. So another way to say it is, hey, I have a function that rolls dice. You implement it how you want. Randomness, checking an atomic clock, cheating 1% of the time, whatever you want to do, implement rolling the dice, and we're going to implement rolling the dice in our unit test deterministically. So by separating out the randomness from the business logic, we're able to get these deterministic tests. So let's drive on from here and say, okay, what do we need to do next? This is not robust enough. Most likely we need to do some more. I guess we could say the next case that comes to mind for me is it doesn't matter if the 2 is at the start. And I feel like, in fact, in examining the code, I can tell that we're ignoring the 4th roll. So a test that would drive us to better functionality would be, we could say returns 4 when we get 1, 2 at the end. And we could say we get 3 1s and 1, 2 at the end. So looking at the implementation code, I know that this case will fail. And so I'm putting this in to drive us to improve our code. So this is going to be the red step where the test is going to fail. And sure enough, it does, because it's just adding up the first 3 elements. And so what I want to do is to get the 4th one and then remove the minimum value. So this is going to be hard to do off the top of my head, but I am going to look at my cheater code for where I implemented this separately. And again, this is a good reminder. If I'm going quickly here, it's not because it was quick the first time I looked at it. I struggled through it. This is because I've gone through this exercise once, and after the struggling through, this is what I came up with. Demoing those is nice because I can show you an example that's particularly helpful, but you don't get to see me struggling quite as much along the way. So some of my other streams, I'm going to be hitting an exercise for the first time. Next week, actually, we're doing one that I haven't done in years and years, and so we'll see how that goes. But this time, this is a looking back over a previously done test-driven development scenario. So that's why we're skipping over some of the struggling steps in the middle. So let's say here, I think I want to get the roles this is going to be a case where I'm going to make the changes under red a little bit, and I feel like that's safe enough right now. Because I feel like we're going to be able to get there pretty quickly. I'm going to get the roles, and we're going to add an array, and we're going to get one more role. And then what I'm going to do is I'm going to say return roles. I'm going to sort them, and I believe if I'm looking at my code right, sort without any arguments is going to sort these in an ascending order or some kind of deterministic order, ordered order by default. Then I'm going to say a slice. Actually, this does feel a little bit like cheating here, where I'm looking at the values. So let's say slice 0 to 3. So I'm going to start at the first element and then take 3 elements, and then we're going to add them out. Let's make a variable. Top 3 roles equals roll sort slice, and we'll just add them up. Let's just do this just to see if it's passing before we refactor to something fancier. So we're actually both cases where we should have been getting a 4, we got a 3. So that actually suggests the sort order is lowest to biggest. So we're getting the lowest first, which we don't want. Let's see, this is not how I did it last time. Let's see if we can just reverse this. And that works. So sort, reverse, and then take the first 3, then we can add them up. So one thing that we could do so we got our test passing now, we can do a little refactoring. This is like almost the only place that I often use a reduce function. So if I had a utility library, I'd get like some kind of some function here, but let's use reduce. Usually I have to look up the API of reduce, but because I'm copying from over here, I can do it now. Got an accumulator and a value, and we just say accumulate plus value. So this calling reduce here is just going to run over each element in our array and add them up. This is just a simple way to say sum up this array. And I save that and it still passes. Oh, I'm now big enough on Twitch that I have a spammer. Goodbye, spammer. Let me find out how to do it. Reported. Spam. Maybe we'll, goodness gracious. Came in my stream. Seems like we need some way to do that more efficiently. Can I? Thank you for reporting him. I appreciate it. It's still showing in the list though, so I'm going to need to research this after the stream to make sure I can get rid of spammers appropriately. So, okay, back to the functionality. So we've got our rollability now that's now taking the top 3 elements. So that's good. I'm going to look and see what other tests I did last time to see. Yeah, so one thing we could do, I think this one's going to pass right away, but I think it kind of helps me to visualize it. And we could, let's just say, return 6 when we get 3 2s and 1 1, and we don't care about the order. So 2 2 1 2. This will just is a nice double check to confirm it's working. It's not strictly test-driven development because we expect it to pass right away, but I think this is good for safety and for documentation. All right, we got 6, we get 3 2s and 1 1. And now I just kind of want to visualize, hey, when that last number bumps up to 2, we can say return 6 when we get 4 2s and make sure that that last number changing doesn't change anything. And sure enough, it doesn't. So this is great. So now we've got our 1s cases, our 2s cases. We've confirmed that it's adding things up. And so I think at this point, we can kind of go straight up to the maximum. So let's go up there. Let's talk about that other boundary condition at the top. And so we want to say, when do we get 18? I'm going to say when we get 3 6s, we want to get 18. We'll just say 6, 1, 6, and 6. Just throw the 1 in there to make sure it's not requiring all 6s or something like that. And we think the total should be 18. And sure enough, that passes. All right, great. So we're making real progress here. And we've now specified a number of different scenarios. And as we go back and read through them, like, check it out. We can just see, hey, yeah, if these are my roles, this is my output. If these are my roles, this is my output. And we've written our unit test in terms of the domain, in terms of the business rules here. Now you might be wondering here, all right, we're passing in roll die, but that's not going to be useful in production, and now it's more complex. I have to pass something into rollability. How can we handle that for our production code? And I can show you how we can handle that. the way, and I've picked this up from the Ruby community, it's the idea of a dependency injection with a default. So the idea would be that your code by default specifies what the dependency is going to be, but you can override it in a unit test. And that keeps your code nice and easy and simple to call in production. And really what we can do here is define a function to roll the dice in production. We could say roll random die. And this is 1 plus math floor, math random times 7, which I think is actually to do. I think this is not quite right. But we just say, okay, that function, that's going to roll a die. It's going to roll a different die every time. And we just say, okay, the default is going to be if we don't pass in any argument to rollability, then this object is going to default to an empty object. We're going to try to pull a roll die property off it. And the reason I do that is I just love named arguments, especially for something like this, where it's this dependency that's not expected. I want to name what it is so it's kind of self-descriptive. And by default, if we're not in a unit test where we're passing in roll die, we want to roll a random die. That's our production dependency. And in our test, we override it by injecting our own die roller. So when I save this, I expect that the tests are still going to pass because we're not using the default dependency. We're going to use our injected dependency in our unit test. And sure enough, they do still pass. So there's not really a good way to test this default dependency in a unit test. It's by design. A unit test should be deterministic. And so what I would recommend instead is that you just test that for production use. We don't have a full application here because this is just a code exercise, but you try it out. You pull it up in the web browser or a command line or API call or whatever, hit it a bunch of times and make sure that those random values you're seeing are something that you'd expect. And debug the issue here where I think this calculation is not quite right. So that's how you use a default dependency. All right. Yeah. All right, so let's kind of go on from here and see what's next. I'll say again, if anyone else has joined in the chat, please feel free to say hello. So glad you're here. Hope this is interesting. Link in the footer gives you information on the exercise we're working on, building out this code exercise from Exercism to build the Dungeons & Dragons character generator and dealing with all the random values as a result and figuring out how to do it. Loaded Hazard says hello. Hello, thank you so much for joining. And to anyone else as well. And again, please send me in the chat any questions you have or afterwards on Twitter or whatever. Please get in touch and let me know what questions you have about testing or TDD or what things you'd like to see me TDD on the stream. We'd love to do that together. All right, so let's move on from here. So what's next? What's the next test that we have specified for us? And I'm going to delete this existing test because I don't think we need it anymore. We have this specified in a way that I like a little bit better and I think helps us. So the next test says ability score is only calculated once. And again, this is the test where we generate a new character and this character has a strength attribute and we're making sure that it stays the same between the two. So that's kind of made a big jump already. And so I want to take smaller steps towards this. So let's think about this. Yeah, so let's take this one step at a time. I want to test these different attributes of the character. Even before I can make sure that it's only calculated once, I just want to see that it's there and that it has a good value. So let's make a new describe block, maybe outside of this describe. I'm going to put it, what am I doing here? Where's my, there you go, describe, yeah. Describe attributes. So we're going to look at a number of different character attributes. And we're going to start with the strength attribute. I try not to nest too much, but I know there's going to be, putting the attributes together will be a good idea. I know there's more than one attribute, so I'm just going to create a strength block there. And I know to get something more than a static hard-coded value, I'm going to need several tests. All right, so let's think about this. So let's say I think what we want to do here is, again, use this random value here. We want to be able to pass in these abilities and see what the strength value ends up being when certain die rolls are made. That way, we're going to confirm what works out here. So for the strength, let's make a die roller again. And let's just start it with all ones again. 1, 1, 1. And it looks like make die roller is not available here. So let's move our function up a level into our D&D character so it'll be available. we've got our roll die, and then we're going to say const character is new character, and we say expect character strength to equal 3. Again, if we're letting randomization happen, we don't know what value we're going to get. In this case, we want to pass in the die rolls that we have, all ones, and know that we get a 3 out. And actually, we want to pass that dependency injection in again. So strength is just a property on the character. It's a computed property. It's a getter, but that doesn't take arguments in. So the place we can pass in the dependency is when we're creating the class on the new character. So we're going to save this test, red, green, refactor. We're going to expect this to be red. And we get this thrown error, which again is the default put in by Exercism to let us know we've got a new function here that we want to implement. Remove this statement and implement this function. We'll make the smallest change we can to change the error, or to the test output. So we're going to remove that error, save again. We'll see. We expected 3 and we get undefined. So for our green step, to get the test to pass, we want to implement, again, the simplest possible thing we can do to get this test pass. And for this would be return 3. That is the simplest way to get this test output where the test is specifying we need a 3 back. So it's passing. Clearly this is not what we need to get the strength to work, so we need to go on from there. And so, actually, it's surprising, an interesting thing about just syntax that this passes even though it's not in a test, it's just in a describe. So I want to put this in a test. And let's say, what are we going to call this? Let's say I'm less focused on the exact number in the die rolls because we tested that up above with rollability. So I think here I might say test is set from a die roll. So we're just kind of confirming that the strength is set based on this die roll. And now that test passes. So what can we do to make sure to move us beyond the 3 here to get a dynamic strength that's set based on the die rolls that are passed in? And we could just say it's set from another die roll. This is a kind of test name you wouldn't get in test after development usually, but for test driven development, like I just need 2 different dice rolls. Dice roll? Yeah, I guess dice roll would make more sense. I just need 2 different tests with 2 different dice rolls to prove that it's being set appropriately. And just for something different, maybe we could say, all right, well, this is just 2, 2, 2, 2. And we make sure that we get a 6 out as a result. And that's not going to work because, and again, this is as expected, intentional. We've gotten a red in our red-green refactor cycle. So now our test has specified that we need the strength value to change sometimes. So how can we do this? And again, you might be able to do a way to get a kind of hacky conditional. But what I want to do here is to go ahead and have it work based on the roll die that was injected. It's a bit different here because now we're injecting this roll die dependency into the class constructor. And so we need to save it at that point. So I'm going to check my little cheater guide here to see how to do that. And maybe next time you'll see me struggle a lot more because I don't have my cheater guide. So we need a class constructor. And that constructor needs to take in the roll die dependency. And we can go ahead and put the roll random die as the production dependency there. And we're going to just save this as a class property. An instance property on the object we're creating. So now we have a roll die there. And so then what we can do here for strength is we can just say return rollability. And so rollability is a static method, so it's not called on an instance of character, it's called on the character class itself. So let's just say character.rollability. I forget if there's a shorthand in JavaScript, so we'll find out in a second. And I need to pass this dependency along, so I'm going to say roll die is this.roll die. So that's how I'm saving this dependency injected in the constructor, and I'm accessing it down in this computed property, in this getter. So this passes. So now when we have these rolls, we get this strength, and we have these rolls, we get this strength. So that's nice. Incidentally, I want to see if I can call this without, I don't think I can do this. That's not going to work. No, I need to do that. Can I do this dot rollability? I don't think that'll work either. Sure enough, it does not. So I could look into that later. Maybe there's some way to say call this method on the current class, but character.rollability is fine for now. That is good enough. All right, so let's think about what's next. Before we say, there's this test up above that said, oh, we should have the strength be the same. It's only calculated once. And so it's so that's interesting. Calling strength on the same character multiple times is only calculated once. Let me think about that for a second. I'm thinking about the way I solved this last time. So first, before, why is the test asking this? Asking if the strength is different. One of the reasons is that they're expecting that the strength value would in fact be different on different characters. And so let's test that. Is that going to be easiest, or is this going to be easiest? Man, I'm struggling here. So this is good. So I still need to think. So there's two different directions that I could go here, actually. Because not only do I want to make sure that the same character has the same strength when we call it multiple times, I also want to confirm that separate characters have separate strength values. Let me check my notes again to see what's going to be the most helpful here. Only once for one character. Rolled separately for separate characters. Yeah, the order that I did this when I was preparing this, I actually don't like anymore. So let's take this in a different order and we'll see how it goes. So I'm going to say, I am going to go ahead and do this and say test is only calculated once. Or I may even say always the same for the same character. Maybe that's an overly broad statement, but I think that's good enough for our test for right now. And so let's we'll roll our character. We'll get a nice set value. Oh, no, I know what it is. So we could say, okay, we got our die roller here. We want the strength to always be equal to 6th. And instead of just comparing it to itself, I think I want to make the assertion twice. I want to say, check the strength that it's 6 and check it again that it's still 6. And I'm going to even add a comment here so that we know that's not a mistake. Check strength a second time. There's maybe another way you can do that, but I like that well enough for now. So what's going to happen here? I guess we'll see. Like let's figure this out and see. This is what we would specify if we want this to actually succeed. The test runs, and instead we get our old friend in JavaScript, nan. So why is strength nan the second time? Let's see what's happening. When we call strength, each time it's called, we call rollability. And each time we call rollability, we pull 4 dice rolls, which incidentally, I could probably refactor that some more, but we'll save that since that's not the main focus right now. And since JavaScript does not have a standard library, we have verbose stuff instead. So this is interesting output, and it's actually kind of surprising output. And so it's like, when I saw this and I was working on this, I was like, well, I think there's maybe another case. Like, what are we doing? Why is it trying to pull more dice? And I see why. But, I think this does work. I think we can do this. Like, the output is kind of weird and requires us to dig into what's happening to see how it happened. But I think this is still something we can take this red and we can use it to drive towards our functionality that we want to have. So we'll do that. We'll just make sure to come back for this case I have in my head. In fact, I'll add a test here and say to do, right, test for 2 different characters. For different values for different characters. And in fact, even more than a to-do, I think it's fine. We'll work on it with that. So what can we do so that the character's strength is 6 both times? Well, what we want to do is to calculate that value only once. So how can we do that? I'm going to see how I did it before for inspiration. We can use some defaulting. We can say this dot underscore strength. So this, character dot strength is our computed property or our getter. So we can't assign to this dot strength. That would break everything. So instead, we'll use the kind of convention of underscore to be like a private value. There are private fields in JavaScript now, but we won't get into that on this stream. So we could say this dot strength. And we can say, use this kind of shorthand that says or equals. Where if this dot strength is a value that's present, we'll return it. Otherwise, we'll assign this value to it. We'll call character dot rollability and assign it to this dot underscore strength. And we'll still return it. Like that'll still be the evaluated value. So this is sort of a syntax for memoized values, as long as strength can't be falsy. So if strength could be 0 or null or an empty string, then it would not just get set once, it would get recomputed again and again. But because the strength value is always going to be 3 or more, this is a safe way to do it. So I think that this memoization will cause the test to pass because the first time we call character strength, it's going to see that this is falsy, and so it's going to calculate rollability, assign it, and return it. And then the second time we call character strength, it's going to see that underscore strength is present and return it as is. So I think this is going to make the test green. And sure enough, we're good to go. So that's very exciting. So now let's go back to this test that I want to write, that the strength is different for different characters. This is one that I think is going to pass already, but I do want to document it just to kind of specify that important thing. Is rolled separately for separate characters. And so let's say maybe 1, 1, 1, 1, 2, 2, 2, 2. So we're saying here that in the sequence of dice rolls, we're going to roll 4 1s and then 4 2s. And so we're going to get 2 different characters. Character 1, character 2. I guess we could pass 2 different die rollers into them, but I think even just having this as a sequence kind of makes sense. Alright, so we're going to say character 1 strength is 3, and character 2 strength is 6. So we want to make sure that there's not some kind of saved state across the characters. And I think this is going to pass right away. And it does, so that's nice. So a way, what this is preventing is if we had some kind of static value out here instead, let strength. So if we stored the strength value like outside of an instance, then this would fail because it would always be 3 because we just calculate it once and then we're done. So this just confirms that the data is stored separately for the separate characters. So that's a great place to be. All right, so let's see where we're at. We've got attributes, we've got strength. It's set for these different situations here. We've implemented what that previous test was. Ability score is only calculated once. And we made smaller steps towards it. Instead of just directly jumping to making sure strength equals strength, which actually I could have tried to make that pass and just returned. Actually, I think it would have passed by default because, well, undefined might not equal undefined, but if I put in any value there, it would have passed. And so that was not enough. So instead of this test that was, I think, not sufficient, instead we've kind of gradually test-driven out what we needed, where our strength is set from a die roll and set differently from another dice roll. And it's always the same for the same character, and it's rolled separately for separate characters. So we've now specified these various aspects of the strength attribute to give us what we need and to really drive it out. And as a result, we've made sure that our test really covers what we need the functionality to be. All right, well, we've got some more time, so let's move on to the next test. So now random character is valid. And character is valid. We get the character, and oh boy, there's a lot going on. All right, we're checking that the strength is between 18 and 3. We've already seen the less than or equal, greater than or equal, and we've seen a better way to do that. Dexterity, constitution, intelligence, wisdom, charisma. That's a lot of attributes. And we've got hit points as well. So there's so much going on in this test. This is not a test-driven approach. We want to gradually get there. You know, we have a strength already. Strength is already working. We got to that one attribute at a time, but now we've got all these other attributes at once. And so now it comes to mind what to do next. Dexterity is going to act a lot like strength. From our requirements in the README that we had, it should be just the same. The dexterity should be just a value between 3 and 18. It should be rolled separately for separate characters and the same for the same character. And so when you see these extensive test-driven unit tests like this, or just extensive tests you write, and you just see this mountain of functionality you need, and you're like, oh, it's so tedious. I can either write all these repeated tests for all these situations, or I can have this one test that just kind of does it at a high-level pass, and then we're done. Even though I could get this test to pass by just putting in a hard-coded 3 for dexterity, constitution, intelligence, wisdom, and charisma. So that's not really covering our functionality. So what can we do? Well, we can go with a technique that I don't actually use very often. This is not, I don't think, come up for me before in production code, but I've seen others refer to, and it works out somewhere here as well. And what we can do is to use a loop. We can actually use a for each, and I tried this out and confirmed that it worked, that it actually, you can use a for each loop inside a jest test, and things were passing. Probably I should have checked to make sure that they were saying this is officially supported before I talked about it on a stream. So if this is not officially supported, I'll come back afterwards in the notes and say there's a better way to do it if there's a better way to do it. So we're going to check this out in just a second. Ori Chandan says, usually watching someone else code is boring to me, but damn, you good. Well, thank you so much. I watch some very energetic streamers. I don't think that I'm as funny as them, but I'm trying to be excited. And like I said, I'm low on sleep, and so I'm a little loopy today. So that's really great. But Ori Chandan, thank you so much for the encouragement. I appreciate it. I hope it's helpful. I want it to be helpful, fun, interesting, and useful that will help you writing your unit tests in the future so you can be confident you've got tests that are helping you, they're covering your code, they're supporting you for refactoring in the future. I really am just way too obsessed about testing, but hopefully it is helpful to someone else. So let's kind of check this out. And in fact, I think I am going to start with a copy and paste to begin, just to take these gradual steps. We're not going to copy and paste everything. We're going to gradually go. Dexterity. So we've got our whole strength describe block here. So let's paste it, and let's just get updated for dexterity. We'll use a good old Command D that's been in editors for the last 10 years. Dexterity. We'll just update all the tests at once. Run them. They're all going to fail. We zoom up here. All the dexterity tests fail. And so what do? Well, we can just copy this over here. Implement dexterity. There might even be a way to reduce this duplication, but it's not too much. It's kind of a simple function call. So whatever. We save it, and it all passes. So we've now got two attributes that are tested. And if you wanted to, you could, remove parts of this to make sure it breaks when it doesn't, and that just ensures that things are really working. We do take out rollability, make sure it really fails. Okay, cool. So this is really forcing us to have dexterity there. So what can we do to avoid having to copy and paste this? Because man, if you copy and paste this 6 times for all the attributes, and something changes about the way one of your attributes needs to work, it's just going to be tedious to read the test. You're going to be overwhelmed. I love reading tests, and I get overwhelmed, and so it's not going to work. So let's see if we can get a loop going here. Let's say const attributes, and we'll just start out with just strength and dexterity. Almost right, or wisdom. I've been watching some Zelda streamers or jokes recently. So now we say, okay, attributes for each attribute. And let's just see, actually, let's just get one working at first. Let's say it's just strength. And in fact, you know what? Let's take a smaller step, because it's nice to take small steps, especially when, like me right now, you're kind of uncertain, like, is this going to work? So we'll say attribute. Just in this strength block, we'll say attribute is strength, and we'll just replace .strength everywhere in here. Just the way that JavaScript syntax works, we can put this in square brackets. Square brackets on an object looks at the attribute based on that string, and it works with getter functions as well. So I expect that this is still going to pass, and we're still good. And if we break strength, our strength tests break, so that's good. We've kind of confirmed that everything's still passing. So now let's take another step, and let's switch this hard-coded attribute to a loop. Let's say, okay, the attributes is now an array. And now let's say for each, attributes.forEach, attribute. And now that's where we're getting our variable from. So now, oh yeah, I don't have, I'm surprised I didn't put prettier in here. It's because I wasn't already on the stream. Usually I have prettier for auto formatting. So now let's see if we're calling for each to get the attribute out of the array, if our test is still going to pass and it's still going to fail if things don't work. Well, looking at the output, we do see the strength test outputted. If we break our strength attribute, they fail again, so that's good. And so now what I think we're going to be able to do is, let's take ourselves out of this describe block, because it's now not just about strength, it's through others. Let's add dexterity. And let's see if we get, oh, you know what? We might even be able to put a describe block in there. Well, first let's save and see if it's outputted correctly. All right, well, our 8 tests are passing, and we can make sure that dexterity breaks. It does. And that strength breaks. Yep, so it's ensuring that both strength and dexterity are working. But we got this big long list here. Well, let's remove this dexterity hard-coded block that we don't need anymore. So we're just using the array of attributes that we're for eaching over to call. But now this list is getting long. And attributes is set from a dice roll. Attributes is set from a dice roll. So if one of those breaks, it's going to be hard to tell what exactly is going wrong. But let's see if we can call describe here. Describe attribute. And just pass in the name of the attribute there. I think I might have forgotten to try that in my other code. So let's see if it works. If this works, then our dynamic values here are going to be outputted in our test structure. So let's give it a try and see. Nice. Strength tested, dexterity tested. Let's add our other attributes one at a time. Constitution fails. Copy constitution. We may want to have a test as well to make sure that the attributes don't overwrite one another. Let me add a to-do for that. Let's do a to-do there. I'll make sure the attributes are rolled separately. But say constitution's passing. And let's see what else is next. Let's put this, because we don't have prettier right now, unfortunately. Let's put this on several lines. Intelligence. That works. And let's go ahead and just add the others. Wisdom, charisma. Our 6 attributes. And now we just pass these. Intelligence, wisdom, charisma. They're all passing. We got this nice structure. Check it out. This is cool. So incidentally, I wasn't even planning to say anything about this, but I'm going to say it. So this is cool. This has not come up for me before, but it's come up now. In other languages that have used this kind of describe block style test approach, like RSpec in the Ruby language, I've seen this similar kind of dynamism where you can have this looping happening. And another approach to unit testing is a class-based approach. JUnit is one big example, where every test suite is a class and every test is a method. And folks will say, hey, this is just Java, it's just Ruby, it's the language you're used to writing. And so it's simpler than this DSL, domain-specific language, where I need to know to write, describe, and test. And if it's X test, then it's skipped, and all this nonsense. Like, I just want a class that has methods on it. Let me just write that. That'll be my tests. But if you do that, and if you're in a language like Java, where, I think JavaScript classes as well, where you can't like dynamically add a bunch of functions inside a class declaration, like your test is very static. But because JavaScript is a very dynamic language, and because this Jest uses function-based approach for these nested functions to find the test, all of a sudden we were able to drop in a for each and add this loop to dynamically get these tests, where we're generating a whole set of tests for these 6 attributes. We write the test once, and then we just make an array and we test them all. And so it's a bit of a downside that I didn't check the Jest docs or references to make sure that anyone's saying, hey, this is okay, this is safe. You don't need to worry about you're going to shoot yourself in the foot with something. But it's actually kind of exciting that I didn't need to check anything. I just had an intuition based on the way JavaScript works. Like, hey, these are function calls. I'll bet you if I just call them in a for each loop, it'll be just like I just had them repeatedly here, one after the other. And actually, as I'm talking through what's happening here, this is increasing my confidence that this approach really works. Because describe is just a function provided by Jest. We give it an arrow function to call. And so the body of our describe block here is not a special JavaScript syntax. It's just a function that's run. That's why I can declare a variable. That's why, when I don't have this loop, like up here, I just have a describe function, and I pass it an arrow function, and inside it I call the test function every time I want to add a test. And so if you think about it, what's happening here is just the same. I've created this attributes group, and in there I'm just calling describe in a nested way repeatedly. It just so happens that that's called inside of a for each. So just my intuition about how JavaScript works allowed me to add this dynamism here, whereas things would have been really tedious if I was using a test framework that was constrained to only use classes and methods inside of it. So I say that not because this comes up too frequently, but just because I just love the describe block style with nested tests. I actually use the it, and I feel like that's more common in Jest, is to say it instead of test. But either way, this is called spec style tests, and I just love the way they work because they allow this kind of nesting. You don't want to nest too deep in a way that causes problems, but you do want to nest in a way that's going to give you this nice clear output where you can see D&D character, attributes, strength, here's what's going on, dexterity, here's what's going on, and everything like that. So just kind of a spur of the moment thing, but I really like Jest. I really like this spec style test framework. So luckily that's pretty much the default and what's almost always used in the JavaScript world. So between that and JavaScript's dynamic language nature, we get a lot of benefits there. All right, so there's more to go for this, but that's all we have time for today. I do need to make sure the attributes are rolled separately. And actually, let me break the code here to make sure that we show that there is a problem there. And what we're going to do is just have all of these assigned to the strength attribute there. This is very bad. This is not what we want to do. Write test to drive us to store these attributes in separate properties. So I'm expecting, and you may have noticed me kind of call my shots here, where I say what I expect to happen before I do it. This is a great way to kind of get your mind settled and be like, okay, here's what I think I'm doing. Here's my understanding of the code and what I expect to come out. And so if what you see is not what you expect, then you can kind of think about it. Otherwise, you might just move ahead. Oh, things are green, I'm good to go. So what I expect to happen here is that tests are going to all pass, and that's a problem. That is not good in this case. That is bad because we do not want the test to pass when we're storing every attribute to strength and they're all the same. We save. All the tests pass. That is not good. That is bad. That's a problem. We have something we need to write here to drive us to store these attributes in separate properties. And you know what? Let me end. Oftentimes there's an advice that folks give where if you're in the middle of something, end on a failing test. So let's end our stream on a failing test. I'm not going to come back to this exercise next time. I think I'm going to finish it up myself and push it up on Exercism so you could see it there. If you check out the link that's in the notes to the YouTube video when it's posted there, or the link that's in the footer of the video feed, you'll be able to get to that Exercism exercise that's pushed up to see my final situation. But let's follow that advice to end on a failing test. And so this is, we've got separate attributes being tested here. And so let's say test, it rolls and stores attributes separately. And similarly, to making sure the attributes are separate for separate characters, let's just go and copy and paste that test. That's kind of in here. Make sure the attributes are separate. So we'll say, hey, when the die roll is 4 1s and 4 2s, we have just one character now, and we say character dot, well, I was about to say character strength, but that makes me realize that this could go in the loop as well. No. It's gotta at least enough to get this to break. I don't know how I'm gonna ultimately do this to make sure it covers all the attributes, but we'll say strength and character dexterity. So we need to make sure. So what we expect, what we want to happen is when we have 4 1s and then 4 2s, and we get a character, when we access 2 different attributes, we want those to be 2 different values. We want the first one to get the first set of rolls and the second one to get the second set of rolls. So I expect that this is going to be our failing test where we can end, because I expect, based on this implementation, that our strength is going to be written once and then going to be read from down here, and that's not going to be good enough. We want them to be stored separately. So we save this test, and we see that it does start as read, which is what we want in test-driven development. We have proven that our code does not roll and store attributes separately. It is storing them together somehow. We wanted to get a separate strength and dexterity, and we're getting the same value for both. So that's the read that we're going to end on. Just like you might end the end of your workday before you pick it up the next day. You end on a read test, maybe not committed to source control, but just sitting there waiting for you to remind you what to do when you get back, especially when you know there's a bug and there's a problem in the code and you don't want to forget. All right, so that's it for coding. Go over to the chat. Ori says, do you multi-stream on Twitch and YouTube or only Twitch? Right now, I stream only on Twitch. That's because my streamer setup is very basic. I'm only just now getting back into streaming after about a year away. But I'm curious, if you would like to see me stream on YouTube as well, or others would, let me know. I can look into that and Google around. It seems like it's probably not too hard to multi-stream onto both. But yeah, what I do is I stream on Twitch, and Twitch captures the stream and puts it up so you can access it for some limited amount of time. I download it, edit it, and put it up on YouTube so that it's available on YouTube going forward indefinitely. So that's where I do it for now. Well, thanks everyone who joined. I want to say thanks to Sean Jane, not thanks to Spammer, but thanks to my first Spammer for joining. That makes me feel good and like I'm kind of growing an audience here. Thanks to Loaded Hazard and to Ori Chandan for joining and for participating in the chat, and anybody else who joined and just watched, thank you so much as well. And if you're watching this later in the recording, thank you so much as well. I do want to thank Exercism for making this exercise. It was so much fun. I just love stumbling across it. And I learned a ton about testing random code here by doing this exercise. So I hope you did for me streaming it as well. I just remembered on this exercise that the Exercism source credits goes to Simon Shine and Eric, I'm not going to pronounce this right, Shireboom. So those were the folks who first created this D&D exercise. So thank you so much to them. I love it. I'm hoping to stumble across future Exercism exercises as well. I'm going to be doing it on my own time. And when I find an interesting one, either before or after I made progress on it, I'm going to do it on the stream. Next week, we're going to be doing something different. I am going to be back next Tuesday. I told myself I'd get the dates ready in advance so I could say it easily. So I'm going to hope to do that next time. And I can't do math in my head. That's why I do test-driven development. So next Tuesday is December 29th. So the same time on December 29th, which is 5 p.m. Eastern, I'm going to be streaming this. I might do a longer stream that day, actually, because I'm going to be doing kind of a research week at work, so my schedule is a bit more flexible. So we'll see. Let's say December 29th to stick with the schedule, but check out on my Twitter feed if you want updates on other possible extended times that I might be going, and we could see that. The exercise next time is going to be Roman numerals. So this is a classic test-driven development exercise, and it's nice because it's very focused, and yet it's one that really challenges you as you kind of implement converting from numbers to Roman numerals and back. Interesting challenges come up, and it's one where it's a lot easier to build it one step at a time. It's hard to kind of envision how am I going to implement this all from scratch. And so the Roman numerals exercise really shows the incrementalism of TDD and how it can be very beneficial. So that's next week is Roman numerals. Maybe some other stuff as well. If we go longer, maybe I'll throw in some other fun things. Future weeks, I've got some kind of small projects or small exercise ideas of my own we might get into. Again, if anybody has anything that you'd like to see me test drive, I'd love to do it. Please give me a challenge. If you think it's a bad idea and it can't be done, or you'd love to test drive something and you don't know how, please share it. I'd love to try it out together. And I don't use test-driven development for everything, but anything that's small and complicated like this, I love using test-driven development for. It's how I have confidence that I have good unit tests. Thanks again to everyone who joined. If you want to go to my website to stay in touch, codingitwrong.com is the website. Right at the top, you can get access to my Twitter feed, back to this Twitch feed, YouTube channel where you can see all the recordings of my past streams. I've done past series on React TDD, React Native TDD, some Ember.js and Rails as well. And you can get to my blog as well, where I write about programming and agile development and testing topics. So thanks again for everyone. Please be safe out there. Things are still rough with the pandemic. We all need to take care of one another. So please be safe. Please protect one another. During the holidays, it's tough. You want to see folks. Do it if you can do it safely. Do it virtually if you can. It's real important. It's a rough time right now, so we really need to help one another out. Ori says a few more things. I wanted to ask something I came across if you had time. I came across a use case where I needed to test TypeScript types in a TDD style. That's interesting. I haven't done a ton of TypeScript. We've actually just introduced it into the client app that I'm using now in a very small way. And so we've just gotten started with it. Types, any kind of static typing is really interesting. It just presents very different challenges than a dynamic environment like JavaScript and TDD where you are kind of checking the dynamic behavior of your functionality. So Ori, I would say I'll leave the chat up for a few minutes because I'm not positive if Twitch chat goes away afterwards. So if you have any more details to share about what you're looking to do, like what is it about those TypeScript types you're wanting to verify? What do you want to make sure is the case? Let me know. In the meantime, I'll look around to see what people have to say about testing TypeScript types. Ori says, I've done a bit if you want some example, but I don't know how robust my testing is. So Ori, I would say if you're on Twitter, hit me up on Twitter, at codingitwrong. You can find me on codingitwrong.com as well. and you can share those examples there. I'd love to see it. I'd love to dig in and assess it. I'll be kind. I won't be judgmental. It's all new to me as well, so I'd love to learn from you about testing TypeScript types. So yeah, please share what you can if you want. I've got an email address on my website as well if you'd rather email, if that works better. So yeah, please let me know what you have. I'll see what I have. And sometime soon, maybe that can be part of the extended time on the 29th. We can share and talk some. If you can make it, or if you catch it afterwards. But yeah, I'd be happy to share a bit about how I would think about testing TypeScript types. When it comes to these things, often the most interesting question about how can I test this is the question, what do you want to test? Or what can I get out of this? What is the value my tests are looking to achieve? And that sounds very esoteric at the start, but really it's very practical and pragmatic. And we'll talk about why. So yeah, Ori says he'll reach out on Twitter. He or she, they will reach out on Twitter. Thank you so much for that. Thanks for the interaction. I love this challenge. I'm going to be excited about learning about testing and TypeScript together. It'll be a lot of fun. Cool. I need to run. There's this crazy Jupiter-Saturn thing where the planets are like overlapping one another just about. The best day was yesterday. Today's going to be good as well. My family and I are going to go try to see if we can see it. So I need to run, try to look for planets. So I'm going to roll. Thanks everyone for catching live and catching the recording afterwards. It's been a blast. It's been a lot of fun. I've been very energized by this. Excited for my holidays getting started. I hope y'all get a break for the holidays if that is in your culture and in your company schedule, or whenever you get a holiday. Please check me out. Let's connect next week on December 29th if we can. Thanks everyone, and we'll catch you next time. See ya.